Okay, welcome to this new lecture on PBMS problem solving. I am expecting you guys to learn normalization, right? There are videos of IGC available as well that can help you to learn normalization. Maybe your professor, your lecturer did taught you. So today we will be actually talking about the most important concept of the entire syllabus, where questions have been asked very tricky of lately. And if you don't have a good concept, then sorry, it's very difficult to answer the question. So this the idea of these lectures is to make sure that you are able to solve the questions. You are able to reason through how people are solving, how I solve the question. And also this is one of my favorite topics, normalization. So since it's my favorite topic, I would always love to teach this topic. So let's start then, okay? So let's start with the basic about. If I start the lecture in a very simple format, if I ask you a very basic question, why do we do normalization? Acha, first of all, what is normalization? Why do we do normalization? Why do we normalize a table? What is the use? Anyone who can answer? To eliminate redundancy. Okay, what kind of redundancy? See, okay, I will take some time to talk about this. Okay, but please make sure you are knowing all this. Okay. So, see, let's write a schema. Okay, let's write a schema. What is a schema? Anyone? What is a schema? Relation schema. What does it mean? Relation schema is the name of the table followed by the columns, right? That is called the schema. Schema means the name of the table and the column. For example, let's say I have a relational model table of I will give you a real life problem. The real life problem, let's say, is that IIT Madras wants to maintain a database of its students. Okay, IIT Madras wants to maintain a database of its students. Who are the students studying, what course, in which department they are in, and what is the room number they are present in. Okay, so this is what IIT Madras wants to maintain. Okay, so the schema would look something like this. Again, it could look different, but the schema currently would maybe looks like this. It has a something called roll number, okay, which is unique to every student. So I can say it's a primary key, right? It's a key attribute. The person may have a name. The person may have an age, right? And the person, let's say, has a gate rank. Okay. And you want to also store the department the person is in. For example, you will have something called a department ID. You will have something called a department name. And let's say you have a department address. Okay, is the schema clear? Everyone, is the schema of the table clear? What am I storing in the table? Is it clear? Okay. Let's say IIT Madras has 4 departments. One department has ID 1 and I call it CSE. Another department has ID 2, I call it EE. Another department has ID 3, I call it mechanical engineering. And another department with ID 4 is something called civil engineering. Okay. Let's say someone named Aditya joined IIT Madras and he has a gate rank of 502 and he joins in the CS department. Okay. So he has a roll number. Maybe I'll write my real roll number, what I had in IIT Madras. Okay. So this is my roll number. Okay. And my name is, let's say, I call it ADI. Okay. Don't want to write the entire name. And age is that time my age was 23. Okay. My gate rank was 502. Since I'm in CSE department, I will have a department ID of 1. my department name will be CSE, and my department address will be some A1. Okay, some address. The long address is there. Okay. For example, tomorrow, let me print point someone. Shruti joins also IIT Madras. Shruti will have her own number. Let's say CS 25. 25 meaning she joined in the year 2025. And she will be a scholar, let's say, with a roll number of 013. Just giving a random roll number, but this is how IIT Madras follows the terminology. And so let's call her S. Her age, let's say, assume again, don't mind, okay, don't mind. I'm just giving a random assumption. Let's say she's also 23. And her gate rank is, let's say, 181. Okay, just giving a random numbers, okay, don't mind, okay. And she also joined department CSE. So what I have to do here, I have to again write one, again write CSE, again write A1. The same information I write again. Let's say tomorrow Vishnu also joins IIT Madras. He joins in the EE department. Again, let's say don't mind, okay, don't mind Vishnu. And just no department is anyway bad. So E25S002 will be his roll number, let's say. His name is Vishnu. His age is, let's say, 23. He has a gate rank of, let's say, 181 in EE. Okay. And again, I have to write the department ID to EE and has an address of A2. Okay. And let's say tomorrow Jigya joins in the mechanical department. So mechanical 25 S003, Jigya 23. Let's say her rank was also 181 in the mechanical gate. She will get a mechanical engineering thingy and the department ID, department name will be ME, and then she will have A3. Okay. Let's say tomorrow someone else joins IIT Madras in the CSE department. So again, I have to write CS S023. Let's say I call her N, age is 23, her rank is, let's say, 481, her department ID is 1, her department name is CSE, her department address is A1. Do you think I'm unnecessarily repeating some information in the table? If yes, what? What information am I again writing and again and again and again in the table? Or is it necessary? See, all three people who are in CS department, I have to write the entire department details unnecessarily, right? Isn't this an overhead for me to write this every time? Age is okay. Age, everyone, in this case, everyone has the same age, but maybe you can say, maybe if I change some ages, let's say, I say it's 25, 26, 23. Okay. So, but yeah, good point. Age could be also the case if you saw this. But you are seeing, right? Department, I am again writing the same things again. Everyone can see this? Yes. Isn't this a redundancy? What Jigya you were saying? Am I writing redundant information again and again? I'm writing the same thing, same thing, same. If tomorrow again, and I'm just taking 3 columns in department. Department could have more columns. Let's say it could have a department, let's say courses. It could have the instructors. It could have many things, right? I'm just taking 3, right? For example, if tomorrow someone else joins in IIT Madras with a roll number of S026, let's call it P, someone 28, let's say, his gate rank is, let's say, 01, and department ID is again 1, again I will write CS, again I will write A1. So this is redundant. Alternatively, what I could have done was, I could have done something like this. I could have done this. See, 1 second. I could have done roll number, name, age, and department ID. This would be my one table. This would be one table. I will just quickly write as R1, R2, R3, R4. The 4 roll numbers, I just wrote them as R1, R2. I don't want to write them again, like big ones. One was me. Who were other CS students? SVP, right? Or even N. So SVNP. Okay. Age is, let's say, again, I will write some random numbers. Sorry. 23, 26, 28. Okay. and they had a gate rank. Okay, the gate rank I'll put here. 502, 181. Let's say, let's say 181, 502. Again, let's say 180. Okay, some random numbers I'm just putting in. Okay, this is one table, and I have another table that only stores the department information, which is department ID, the name, the address. Department ID is 1, CS A1, department ID is 2, EE A2, department ID is 3, ME A3, department ID is 4, civil engineering A4. What I will do now is, these are two different tables. Unlike keeping one table, there are two different tables, and all of them are CS department. So I will just store the ID. And all of this ID will refer to this table. Okay. So for example, if tomorrow there is another student joining in the CS department, he will have roll number 6. Let's say name is A, some age 32. Let's say gate rank was 54. Let's say, okay, and the department ID I will only set as 1. Everything else will be taken care of. Is it clear, everyone? So breaking down the table into these two tables is called normalization to remove redundancy. Okay, so is it clear, everyone? Which is a better design? Is this a better design of the table or this? What design do you think is better? The second slide or the first, this one? This slide or the next slide? The second one. Do you understand why? I'll give you more examples, okay? The first thing is, so this problem is also called as insertion anomaly, which means every time you have to insert a new student in the database, you will have to unnecessarily always update the department information as well. Okay, is it clear? Yes. Okay. What is the other issue? See, for example, tomorrow let's say tomorrow let's say IIT Madras decides that, boss, we will not call our department as CSE. The name I won't call as CSE. I will change the department name to CSAI. Okay. This was the table. People were there with CSE as a department name. Tomorrow IIT Madras decides, boss, I will put CSAI instead of CSE as a department name. I won't call it Computer Science and Engineering. I will call Computer Science and Department of Computer Science and Artificial Intelligence. In this table, do you see what is the problem when I try to update things? I will have to go ahead and update each row's department name. Do you guys see that? I have to change it here, right? CSAI, 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 CSAI. But over here, what can I do? Can I do something better here? Has the department ID changed? Only the department name says. And what can I do here? I will just change this CS to CSAI. Now tell me, which is the better one? Is the second slide the better design than the first slide? Right? Database design, is this one better or the next one better? Second slide better. Again, the second slide will be better. You can see that, right? So this is also called as updation anomaly. Now let me tell you another problem. Okay. Let us say tomorrow IIT Madras says, boss, here is the thing. What I will do is I will delete the person who is a EE student. I will delete this person because he was maybe caught in some discrepancy, he did something or so other, and he will be rusticated from the college. Let's say, okay, let's assume, okay, IIT Madras decides this, okay, he will rusticate the person with EE from the college. So what will happen is, typically IIT Madras will do something, he will just delete this row from the table. The IIT Madras will decide that, boss, I will just delete this row from the table. Okay. Yeah. So IIT Madras will decide and delete this row, saying, boss, thank you very much. You were involved in some discrepancy. Sorry, your career at IIT is over. What did I delete? The student. Have I deleted something else along with the student? With the looks of the table, what have I deleted along with the students? I even have deleted the EE department information, as if there is no EE department. The entire EE department was dependent on this person, and when I remove this person, the EE department is gone. Does it make any sense? I am only trying to rusticate the student. I'm not trying to eliminate the department at all. Right? IIT Madras still will have a EE department. So, but in the table, do you have any more information about the EE department? No. But what can you do here? What can you do here? You can simply say, boss, this is what I will do. I will just remove this row. That's it. The department still stays, right? The department still stays. Okay. Do you understand the thing, everyone? Do you understand what I'm trying to say here? Okay. So this is also called deletion anomaly. So what are the three anomalies that are present because of which normalization you need to do? Insertion anomaly, updation anomaly, deletion anomaly. Okay, is it clear everyone? Any questions? This is a very basic fund of normalization, right? You should know this. So any questions? Anyone has any doubts? Shall I proceed? Can I proceed? Okay, okay, so good. Okay, so next question. Now if you know this, what are the different normal forms present in normalization? What do you know about normal forms? What are the different normal forms present? Hmm? What are the different? 1NF, 2NF, 3NF, BCNF. Very good. Everyone knows this. There are three normal forms present. And depending on the structure of your table, different normal forms differ in different ways. Okay. So it's like this. First is a table is in 1NF, first normal form. And what is the condition of being in first normal form? What is not allowed in the first normal form? When do you say a table is in 1NF? The table cannot have dash. There is a GATE 2024 question also. We'll look into that, but okay. 1NF, what is it? You are not allowed to have multi-valued and what? And composite attribute. Very good. So composite and multi-valued attributes are not allowed. What does this mean? Very basic example. A person may have more than one mobile number, right? A person P1 may have more than one mobile number. So you can't store the mobile number like this. For example, 1, 2, 3, 4, comma 5, 6, 7, 8. You are not allowed to store like this because it's a multi-valued attribute. You cannot store in a single cell. In a single cell, you cannot store multiple values. You can only store a single value. Okay, is it clear, Vishnu? Okay, so this was 1NF. Okay, what is the condition of 2NF? When do we say that a table is in 2NF? No partial dependency. Very good. What is a partial dependency?
Like when a non-key attribute is derived from proper subset of candidate key.
Very good. Perfect. 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 Very good. So what Jigya was saying is, I'll explain also to people who are not familiar with this. So 2NF mein first is you need to be in 1NF, right? Every normal form requires the previous normal form to be there. Plus, it does not allow any partial dependency. Okay. But basically, what I will tell you is, if you still don't know anything, I'll still tell you how to solve these questions. Okay. When we move to the questions, I will teach you about how to see 2NF. Okay. Don't worry at all. You just need to know how to calculate candidate key, which we have already taught in the last, looked at the last lecture, right? How to calculate a candidate key, how to find a candidate key. If you know that, that is enough to ace the normal form. You can actually do any normal form, you can easily find out. Okay. Just you need to know the candidate key, how to find it. We'll go into that. Okay. So basically, what Jigya was saying is, you cannot have a dependency like this. There is a non-prime attribute. Sorry, there is a uh, there is a primary attribute depending on a non-prime attribute, and this primary attribute is a subset of the candidate key. Again, for people that does not make sense, hold on. I'm just writing it as a quick revision notes for you. Later, when we solve questions, I'll go deep. Okay, 3NF. What is the condition of 3NF? When do you say that a table is in third normal form? No transitive dependency. Typically, it means is you need to be in 2NF, right? Plus, you are not allowed transitive dependency. That may not be clear to people. What do I mean is there should not be a dependency of a non-prime attribute to a non-prime attribute. Okay. What is a BCNF? Boy's code normal form. Table should be in 3NF and what else? Every functional dependency should have LHS as super key. So were you trying to answer someone? Sorry, I didn't give you time. Sorry, I should have. Sorry. Okay. Every LHS or functional dependency has to be a super key. Okay. This is a quick refresher if you want to go through this later on in your notes. But again, we'll look at questions and that way it will be much more clear. Okay. So, but basically this is what it is. And now let's go to the questions starting from a question asked in GATE 2024. Okay. Sorry. Okay, and just to complete your notes, right? Quick notes. Let's also write about non-prime and prime attribute. So, what is a non-prime attribute? Anyone who knows? It was also discussed in the previous lecture. An attribute which is dash. Attribute should be part of the candidate key or should not be part of the candidate key. Should not be part of the candidate key. Very good. Please answer, guys. Okay. Uh, because right. Please answer. Okay. So non-prime attribute is attribute should not be part of a candidate key. Should not be part of candidate key. So if non-prime attribute is an attribute that should not be part of the candidate key, what is a prime attribute? Attribute is part of a candidate key. Very good. Okay. And I've already discussed a lot about how to calculate candidate keys and all that for a given a relation schema with the dependency. So I think that would be okay. Now let us go to the questions part of the thing. It should not be part of the candidate key. Okay. This was asked in GATE 2024 very recently, and it's an MSQ. Sorry, it's not an MCQ. Please ignore this part. I have actually forgotten to edit this part. So it's written is or are true, which means it's an MSQ. So uh, many people might not have thought that there will be a question on 1NF, but here you go. Which of the following statements are true? Is option A true? Okay. Is option A true? I got a false, I got a yes. Okay. Can R have a multi-valued, multi-attribute key? Please read the question very carefully. It's not says multi-valued attribute. It says multi-attribute key. Okay. That's why gate is gate. What do you mean by multi-attribute key? It means the key contains more than one attribute. What is the problem if it has a more than one attribute key? Is there a problem? Is A true? Let me ask the question again. Is A true? Everyone. Why no? 1NF only requires a cell to have an atomic value. That's it. Right? 1NF only allows a cell to have an atomic value. If if a relation R contains a multi-attribute key, there is no problem with it. Okay, so option A is true. Okay, is option B true? Again, listen to what I'm saying. 1NF only permits atomic values in a relation cell. Now, if the relation has a foreign key, it does not have a foreign key. Does it make any difference to the value in the relation cell? It may have a foreign key, it may not have a foreign key. How does it matter? So option B is false. Okay. Is option C correct? Can R have a composite attribute? If you were following my lecture 5 minutes back, you can answer this. Can R have a composite attribute? No. If you read the notes, it's clearly written 1NF mein composite attributes are not allowed, right? So that is true as well. Okay. R cannot have more than one candidate key. Again, read the definition of 1NF. Each cell in a relation must have an atomic value. Now, if the relation has 100 candidate keys, how does it matter? It does not matter. It can have more than one candidate key. No one is stopping. Okay, that's why option A and C are the right answer. Okay, there is one more very, very good question, very common question asked in normalization. I forgot to talk about it. There is some question in the exam as well. We'll discuss that. Achha. What do you think is the best normal form among these four? Let's see if you know that theorem. Which is the best normal form among these four? BCNF? BCNF? Everyone BCNF? Or 3NF? Which is the best normal form? Others? Vishnu, Rohit has answered others. 3NF? Okay, okay. 3NF? Okay. Anyone BCNF? BCNF is 3NF plus some more things. So shouldn't that be better, Jigya? Or do you know the theorem? Why do you say 3NF? What is the reason? Very good. Very good. That's the whole point. So the best normal form is 3NF because 3NF guarantees a dependency preserving lossless decomposition. Okay, we have already discussed this in the last class. Lossless decomposition is decomposition where you don't lose any information. So it is dependency preserving and lossless always if it is in 3NF. But if it is in BCNF, it may not be dependency preserving. Okay, please keep this in mind. Okay, so 3NF is the best normal form. Okay, okay. We have a question also, so look at that as well. So gate, this is gate 2024. Any questions? Any questions in this? Any doubts in this question before I proceed? Everyone okay? Everyone okay, right? Okay, perfect. Yeah. This is also a theorem that you must know. So let's see if you know. The theorem also you can also look at in the concept. Okay. In a relational data model, which one of the following statements is true? A relation with two attributes is always in BCNF. If all the attributes of a relation are prime attribute, then the relation is in BCNF. Every relation has at least one non-prime attribute. BCNF decompositions preserve functional dependencies. If you look at the comments, if you look at a comment by Jigya, you can clearly say that option D is false or true. Is false, right? I mean, that's the whole point. BCNF may not be dependency preserving. Okay. You need 50-50 lifeline. Option C is also incorrect, and a relation can definitely exist with all prime attributes. Okay, there is no one stopping. Okay, okay. Now is option A correct or option B correct? See, it's very interesting saying relation with only two attributes is always in BCNF, right? That is actually the correct answer, but how? Okay, see, let's say there is a relation R1, it has two attributes A, B, right? Relation has only two attributes. Can you tell me what are the functional dependencies possible given these two attributes? What could be the functional dependency? Let's say I could say one could be A derives B. What else? B derives A. Okay, perfect, perfect. Anything else? Anything else? You can please do not give me the trivial dependencies. Okay, trivial dependencies I don't need. Maybe okay. There's these two are there, right? AB derives AB could be also one of them, but again that's a trivial dependency. So let's not go there. Okay. Assume this is the relation. Is this in BCNF? What is the acha? First answer. What are the candidate keys of the relation? What are the candidate keys of this relation? Just A, just B, right? Just A, just B. These are the candidate keys. Everyone agree to it? Okay. The sorry. Is this relation in 3NF? Let's go straight there. It's in 1NF. Come on. I mean, so it's assumed that all relation models are in 1NF. It is in 2NF. Again, this is not a very good example to say whether it's in 2NF, but believe me, it's in 2NF. Okay, for people who know about 2NF, they will be able to also say, is this relation in 3NF? In 3NF, the thing is, if there is a dependency like this, non-prime to non-prime, then the relation is no longer in 3NF. Okay. So what are the prime attributes of this relation? A and B. Is there any non-prime attribute? So is this in 3NF? Yes. Is option C now false? Can you see that? There is a relation with a functional dependency where every relation need not have any non-prime attribute. Okay, that's why option C is incorrect. You can see from this example. Okay. Now BCNF says, boss, 3NF to okay, it's okay. The LHS of every functional dependency should be a super key. Are A and B super key? Every candidate key is a super key. If you remember the last lecture. So are they super keys? So is it in BCNF? Again, same question I'm asking. It's in BCNF, okay? So you might think, boss, this guy has given both dependency. What if I have only one? Now, will the candidate key change? Who is the candidate key now of the relation? Just A. B won't be the candidate key anymore because you can't get A from B. Okay. Who are the prime attributes? Just A, right? Who are the non-prime attribute? B. Okay. Is it in 3NF? Is there a non-prime to non-prime functional dependency present? No. Right? It's in 3NF. See, this is a prime attribute, this is a non-prime attribute. Right? But there, it's not non-prime to non-prime. It is prime to non-prime, which is okay. Okay. Is the LHS of it a super key? So that's why option A is correct. We find every relation with only two attributes will always be in BCNF. Okay. Is it clear, everyone? It was a very, they have actually repeated this question a lot of times. Okay. If you go home and try to see the PYQs, right? This, especially this line, right? This line they have repeated million times. They have also given a question where you have seen those questions, right? There is a statement 1, there is a statement 2. They ask which of them are true. Is it both S1, S2? Is it only S1, only S2? Neither S1 nor S2. So they have also given a question like this. One of the statements is this, that a relation with only two attributes will always be in BCNF. And people might also, again, my assumption will always be that you will also appear for other exams. IIIT Hyderabad, if you appear, PGEE, this is one of their favorite questions. Okay, this is one of their favorite questions. In the last 4-5 years, they have always been asking this. Okay. So also in BITS HD, because you need to find questions from somewhere. So BITS HD and IIIT Hyderabad, their favorite questions are get this one. Relation with only two attributes is always in BCNF. So okay. Okay. If all the attributes of a relation are prime attributes, then the relation is in BCNF. Let's prove this as wrong. See. Let's say I have a relation A, B, C. Okay. Okay. Let's say I have a dependency like this. A, B derives C. Okay. And let's say I have something like C derives A. Okay. Okay. Achha. So who are the candidate keys of this relation? Who are the candidate keys of this relation? Anyone? What is the candidate key of this relation? It's AB. So what are the prime attributes in this relation? A and B, right? CB also? Yeah, very good. AB and CB. Right? Very good. Very good. Okay. So who are the prime attributes of this relation? All ABC? All ABC, right? Because all the attributes are part of a candidate key. Okay. चलो, ठीक है, चलो. So it qualifies the relation that all prime attributes of the relation are prime attributes. All the attributes of the relation are prime attributes. Is this relation in 2NF? Is there a partial dependency? Can you see here? There is a partial dependency. See, what is a partial dependency? Okay. Look at this functional dependency. What is C? Is it a subset of any candidate key? Is capital C a proper subset of any candidate key? Yes, anyone? Is capital C a proper subset of any candidate key? Which candidate key? CB. So capital C is a proper subset of a candidate key CB. Is this allowed in 2NF? Is this allowed in 2NF? Should LHS be a proper subset of candidate key? No. This is also called, this is a problem, and that is why this is not in 2NF only. So you can't say that it will be in BCNF. Okay. That's fine. That's fine. That's absolutely okay. A is a prime attribute. That's absolutely okay. The LHS should not be a subset of the primary key of any candidate key. Okay. Please try to clear this concept out. It's not that A is a prime attribute, so you will say, okay, boss, done. 2NF may, if anywhere you get a proper subset of a candidate key, there is a functional dependency. It is no longer in 2NF. When it is becomes in 2NF, to look at 3NF, you say that A is a prime attribute, so 3NF is okay. Okay, but here it does not qualify 2NF only because there is a partial dependency. Okay, please clear this out. Okay, even I used to have this confusion long back. I cleared it by saying that it's wrong. The thing is, it should not have a proper subset of a candidate key. Okay, please keep this in mind. So option A is the right answer. That relation with only two attributes will always be in BCNF. Okay. So let's go to the next question. I really want to not go into theory now. Let's see if I have a question on it. I do have put an question on. Okay, another theory question. Let's see. Okay, yeah, this is a direct theory question from the notes. So consider a relation table R that is in 3NF, but it is not in BCNF. Which one of the statements is true? Right? This was the last gate which had MCQ, so all the MCQ. Okay. There's a table which is in 3NF, but it is not in BCNF. So what is the problem if a table is in 3NF but not in BCNF? What is the problem? I mean, what could be the problem? Let me ask that way. What could be the problem? Perfect. LHS is not a super key. Okay. So which option is correct? Which option is correct? Yes. Okay, I think I did one mistake in the previous question. I think Jigya, you were correct. I don't know what happened here. So the thing is, what she said was, I think, see, okay, I think I have to. Did I write the correct condition in the notes? I just checked. I was also kind of sorry. See, I wrote it correct, but I told you wrong. Okay, sorry guys. One small error I made. Again, sorry guys. I shouldn't have done that. And thanks, Jigya, for pointing it out. So the right hand side, if it is a prime attribute, right? Always try to remember that if a relation only contains prime attributes, okay, if a relation always contains prime attributes, they are surely to be in 3NF. Okay, please try to keep this in mind. Okay, I think it's a better way to look at this. If a relation contains only prime attributes, the relation is in 3NF. Okay, so it is still 3NF, but sorry, but the thing is, okay, where did that question go? 1 second. Yeah, but still option B is incorrect. Okay, still option B is incorrect. It is still not in BCNF. Can anyone tell me why? See, BCNF it won't be because the LHS is not a super key. So is C a super key? No, right? C is not a super key because if CB is a candidate key, either CB or CB along with any other attribute will be the super key. C is not a super key. That's why B is also not correct. Okay. The answer is correct, which is B is not correct, but my reasoning was wrong. The problem is the attribute, if it has only prime, if a relation has only prime attributes, relation will always be in BCNF. Okay. So please keep this in mind. Sorry, if a relation has only prime attributes, it will always be in 3NF. It may not be in BCNF because of the LHS is not a super key. Okay. Yeah, this question. Jigya, you answered A for this or any? I think A for this, right? Okay. Anyone else? Anyone else? See, first of all, look at option D. A cell in R holds a set instead of an atomic value. If option D is correct, then which normal form the table is not in which normal form? What is the condition of option D? 1NF, right? The table is not even in 1NF. Okay, good. Option C. If a table has this where X is not a super key and A is a non-prime attribute and X is a proper subset of some key, the condition of this is it is. This is the condition of 2NF. Very good. And seeing this option only, I corrected myself. I always get confused. I don't know why. Okay. Option B. Why is option B not correct? Why is option B not correct? A should be prime. Mhm. Achha. Let's see. Let's say this is one thing. Okay. Let's say A B derives C, and let's say B derives C. Okay. Now let's say B derives D, and there's a relation schema A B C D. Which normal form is this relation in? Which normal form is this relation in? First of all, what is a candidate key? Maybe. Okay. So which normal form is this relation in? Is it in 2NF? Okay, no. Let's say I change this to C. Is it still not in 2NF? So the D is not there. Okay. Still not in 2NF. Okay. X is not a super key and X is a non-prime attribute and X is not a proper subset of any key. One second, I'm just thinking of an example. I think I had one. This one is having an issue with the 2NF part, right? And okay, yeah, this one only actually. Okay, is C a non-prime attribute? C is a non-prime attribute, so it's a non-prime attribute. Is B a prime attribute? So X is not a super key, B is not a super key, and A is a non-prime attribute, which is C in this case is a non-prime attribute. And capital X is not acha, okay, fine. Yeah, okay. I think you are correct. You are also correct here because uh, the right hand side should definitely be a prime attribute. Okay. So option A is correct, which means X is not a super key and A is a prime attribute. Why is A should be a prime attribute is if A is not a prime attribute, right? Let's say if A is not a prime attribute, okay, then there could be a case that here I have NP, a non-prime attribute as well. And if this dependency is there, then the table is not in 3NF. I was not able to find a concrete example. I'm trying to explain you like this. What I'm saying is, see, if A is not a non-prime, if A is a not a prime attribute, which is A is a non-prime attribute, there could be a possibility that the left-hand side is also a non-prime attribute, right? Where this is not a super key and this is also not a proper subset of any key. And if a relation contains this non-prime to non-prime dependency, it violates what? 3NF. So if the relation is in 3NF, that means this should not be possible. So option B will not be the right answer because this is the condition of 3NF. Okay. Okay. Anyone questions? Any questions? Anyone confused? Want me to explain again? Shall I proceed? Okay. Okay. Perfect. Perfect. Okay. Let's go ahead to the next question. Finally. Okay. So now you have a real example of a schema they have given, and they have also given the prime attribute, and there's some functional dependency that exists for the schema. Now you have redesigned your database and broken down. I can't see the text. Anyone else who can't see the text as well? I can see. Okay, maybe I'll do this. Now can you see? Okay. So yeah, so there is a database of research articles in a journal. It uses the schema this, and they have also given the primary key. The primary key is volume number, start page, end page, and these are the functional dependencies that exist. The database has been redesigned to use the schema given below. They have divided the table into two different, what shall I say, two different tables. One is this, having volume number, start page, end page, title, price as the attributes. And another is volume number and year. Okay, this is the question. We are asking what is the weakest normal form that the new database satisfies, but the old one does not. First of all, can you tell me what is the normal form of this database? First of all, is it in 1NF? Is it in 2NF? Is this table in 2NF? What are the prime attributes of the table? See, 2NF means it's very simple. You need to check for prime attribute to non-prime attribute if there is something present, first of all, and is this a proper subset of a key? So who are the prime attributes of this table? Come on, that's simple. You don't need to write the entire thing. You can write the first letter, V, N. Right? I am not a professor who wants to punish you by writing all this. So you can, even I didn't write that. This is all copy pasted. V, N, S, E, right? Volume, number, start page, end page. Okay. These are the prime attributes. My first question, do you see any functional dependency that satisfies this? Which is that there is a prime attribute on the left hand side, maybe a 1 or 2 or 3 or 4, and there is a non-prime attribute on the right hand side. Do you see any functional dependency? How about the first one and third one? Aren't they also not something that satisfies this? I'm not telling you whether 2NF or not. I'm saying you, is there a dependency where there is a prime attribute on the left and a non-prime attribute on the right? Yes, all three of them, right? All three of them have prime attributes on the left hand side, right? And a non-prime attribute on the right hand side, right? All three of them. Okay. Now, if you look at the second one, there is a problem with the second one. Yes. Yes, you were saying something?
Okay, yeah, no.
Hello? No problem. Okay. Good that you're thinking also. That's good. Okay. Now, there is a problem with the second functional dependency. Can anyone tell me what is the problem? There's a problem with the second functional dependency, but the problem does not exist with the first and third one. Can anyone tell me what is the problem? See, I don't want to pinpoint people
It's
and
a
ask. Okay?
proper subset of candidate key.
Very good, right? So if you look at the second one, it consists of the prime attributes volume and number. These two are proper subsets of the key attribute of the key given, which is V and SE. V, N are proper subset of V and SE. Now, what did I say? I say this is not allowed in 2NF. So, because of this dependency, the table is not in 2NF. Everyone, did you understand? Everyone understood, right? Or should I explain again? It's very simple, guys. Very simple, actually, if you just think. That's it. So you see, okay, let me go a bit slow. Okay, let me go a bit slow because you need to understand this before your eyes. Okay. So I first of all I asked you what are the key. The key is VNSE. What is VNSE? Volume, number, start page, end page. And so these are also the prime attributes. The prime attributes are V, N, S, E. And so what are the non-prime attributes? Anyone? What are the non-prime attributes? Anyone? TYP, title, year, price. First step is done. You found they have given you the candidate key, but I expected that they would ask it, right? You can also calculate the candidate key given this data, given this functional dependency. But they have given it, that's fine. So they are saying this is the key. We found the prime attribute, we found the non-prime attribute. Now, first you check for 1NF. Every table is in 1NF. That's assumption always, unless they have specified values and the values do not have atomic, then you can say, but it's assumed that if they are given a schema, all tables are atomic, contain atomic value. So all tables will be in 1NF. Okay, that's done. 1NF checked, done, and dusted. Okay, for 2NF, you have to do this. You have to see, is there a functional dependency where there are only prime attributes on the LHS and non-prime attributes on the RHS? Okay, is there a functional dependency, prime attribute on the LHS, non-prime attribute on the RHS? If you look carefully, all the three dependencies have prime attributes on the left-hand side, non-prime attribute on the right-hand side. Okay, is this part clear? Yes? Okay. Okay. Now try to look at each of the three dependencies. Does any of the dependency have the LHS, a proper subset of the candidate key? What is meant by proper subset? Proper subset is a subset that does not include the set itself. So if you look at the second functional dependency, this is volume number. Is it a proper subset of the key, that is VNSE? The entire set is volume number, start page, end page. Volume number is a proper subset of that set, right? So that is a problem that is not allowed in 2NF. That's why you can say that the table is not in 2NF. So what they are asking, what is the weakest normal form that the new database satisfies, old one does not? Old one does not satisfy 2NF. Does the new one satisfy 2NF? This is what they are asking. They are basically asking this only. Does the new one satisfy 2NF? Okay, now let's look at that. Now, if you look at the redesigned schema, the redesigned schema contains two tables. One is this, another is this. Okay. Okay. Now, if you look at the second table, the problem was only this functional dependency, right? This functional dependency was creating a problem. The second one. This will go here. Why? Why it will go here? Because the year, the attribute year is only present in the second one. Is the attribute year present in the first table? No. You can see that, right? It's not present in the first table. It's only present in the second table. Now, what is the candidate key of this table? What is the candidate key of the second table after decomposition? Vn, right? Vn is the candidate key of the second table. Who are the prime attributes? Prime attributes are v, n. Which is the non-prime attribute? Year, right? So you want to check for 2NF. Is there a dependency P derives NP? If you look here, this is P, this is NP. But is this a proper subset of the candidate key? Is it a proper subset of the candidate key? No. So now your relation becomes 2NF after decomposition. That's why option B is the right answer. Okay, is it clear, everyone? Is it clear, everyone? Any questions? Okay. This was asked in ISRO 2014. It's a very, very good question. Okay, that's why I put it. I know it should be a gate, sorry, gate revision, but it's a very good question they have asked. So this is the table. They are saying the table is in which normal form. They have not given functional dependencies. So can you somehow find out the functional dependencies given the table? Can anyone list the functional dependencies given the table? Yes, anyone? What are the functional See, ISRO is an easier exam than GATE. The questions are always easier. So, try to answer. Right. If you remember how I taught you to calculate candidate key, they are actually following the same. They are saying A, B, and there is an outgoing H to C, D, E. Right? So AB derives, you can also break it down and write how Vishnu wrote, AB derives C, AB derives D, AB derives E, or else you can also write it like this. The first step, okay, I will tell you how to actually do the normal forms. So this is I can call step 0, because often every question puts the functional dependency. Here they are put in a table, like a table. So whatever it is, but normally every question puts the set of functional dependencies. Now you try to calculate the candidate key. What is the candidate key of this relation? AB is a candidate key of the relation. Is there any other candidate key? No. If you see, there won't be any other candidate key relations. Okay. Second, again, this you can after practice try to not write, but since we are now learning, so we'll write. List the prime attributes and the non-prime attributes. Who are the non-prime attributes? Anyone? C, D, E. Okay. Now you check for first normal form. They have not given any relation instance, which is any rows. So its assumption is always it is one. Always it is in 1NF. Okay. Now the interesting thing is it in a second normal form? What is the second normal form? To check, what will you do? You will look at the set of dependencies. Is there a dependency like this? Is there a dependency like this, where there is a prime attribute on the left hand side and non-prime attribute on the right hand side? Just answer that. Don't tell me it's a proper subset or not. Okay. Is there a dependency where the prime attributes are on the left hand side, non-prime attributes on the right hand side? If it is a proper subset or not is a different question we'll answer later on. Jigya, if you say no. Let me repeat the question. Is there a functional dependency where there's a prime attribute on the left hand side, non-prime attribute on the right hand side? Which functional dependency is it? AB derives CD. Very good. This is a functional dependency where the prime attributes are on the left hand side, non-prime attributes on the right hand side. Does it violate the condition of 2NF? Does it violate the condition of 2NF? What is the condition? The LHS is a proper subset of a candidate key. Is LHS a proper subset of a candidate key? No. That's why this is still in 2NF. Okay. Second functional dependency, I will not even look into it because that is not what I am searching for in 2NF. I am searching for the fact that is there a dependency where there is a prime attribute on the left, non-prime on the right. In this case, if you see, there is a non-prime attribute on the left, which is okay in 2NF. I don't even bother about it. Okay. Okay. Now let's go to 3NF. In 3NF, they are saying, is there a dependency from a non-prime attribute to a non-prime attribute? Is there a functional dependency from a non-prime attribute to a non-prime attribute? Yes. Is there any functional dependency like that? Can you see? The first one has prime attributes on the left-hand side. The second one has a prime attribute on the right-hand side. That's why there is no dependency that exists with the non-prime, non-prime. So we can say it is 3NF. Okay. Now, how should I check BCNF? BCNF means that the LHS must be a super key. Is there any dependency where the LHS is not a super key? C derives B. C derives B, if you look at it, C is not a super key. C is not a super key, right? So, what can I say? Option, which is correct? Option C. It's in 3NF, but not BCNF. So, please remember all these steps, okay? If you remember all these steps, any normal form question will be able to solve. Okay, first is get a hold of the dependency, calculate the candidate key, find the prime and non-prime attributes, check for 2NF, check for 3NF, And whenever you find, for example, if this table wouldn't have been in 2NF, you need not proceed any further because 3NF requires a table to be first in 2NF. Similarly, BCNF allows a table to first be in 3NF. So please do not proceed if you do not find something like this. If it's not 2NF, you don't need to check for 3NF. Okay. So this was ISRO 2014. This is one of the question. I will give you some time. Please try to solve it on your own. I have already given you the algorithm, right? First, calculate the candidate key, find the prime attribute, find the non-prime attribute, and uh, check for the dependencies. Okay. Please take some time. I'll give you 3 to 4 minutes. Please try to answer. Okay, who are the candidate keys? I think we had calculated the candidate keys in the last class. Same question, right? I did calculate, right? I think so. AD, BD, ED, FD. So the candidate keys are AD, BD, ED, FD. Okay. So who are the prime attributes? A, B, E, D. Sorry, I forgot alphabets. D, E, F. Right? A, B, D, E, F. I'm just writing them in alphabetical order so that it's easier for visualization. Okay. Okay. So who are the non-prime attributes? Everything else. C, A, B, C, D, E, F, G, H. So C, GH are the non-prime attributes. Okay. This table is in 1NF. Is it in 2NF? Yes. How? There is no partial dependency, you are saying. Sure. Sure, there is no partial dependency. Okay. I can see a partial dependency from here only, yaar. Matlab without even moving my pen. How, Shruti? Hmm. How do you get A derive C? From which dependency you got A derive C? Right. Correct. Very good, Shruti. Very good. So can't I write A derives BC like this, Jigya? Aren't they both equivalent if I write them as this or this? Yes. Aren't they both equivalent? Is my question. Now, is A derives C a partial dependency? B derives C, B derives H is also a partial dependency. Very good. Very good. Okay. So what is it? What is the correct answer? You know. Okay. Okay. Understood? Jigya, did you understand or do you have a question? Understood. If you remember the last class, we were talking about dependency preserving, right? I think Vishnu gave a real very good. He corrected me, right, by saying that, boss, there will be a dependency because you should consider that. So that's how I got dependency preserving, right? If you remember that, right? Same formula you apply here, and even they have given you a hint. They are saying F plus is exactly the set of FDs that hold for R. They are telling you that F plus is there. What is F plus? If you remember the last class, what is F plus? The closure set of F, right? What is the entire set of functional dependencies you get? If you try to find out. If you say A derives BC, that's why, okay, I think I should have told you this also. I'm sorry about it. You can do one more thing to avoid these mistakes. Always try to open up the functional dependencies. What do I mean by open up? Which means try to simplify them. In essence, what do I do is I say the functional dependencies are CH derives G, A derives B, A derives C, B derives C, B derives F, B derives H, E derives A, F derives E, and F derives G. Okay, this is not the set of functional dependencies. These are the set of functional dependencies I have. If you try to write it them this way, then you will be able to not make mistake, avoid the mistake. Okay, clear? Can I proceed? Okay, good, good. We have a lot of questions like this, so let's go ahead. Theory question again. Which of the following is true? Every relation in 3NF is also in BCNF. Every relation in BCNF is also in 3NF. Relation R is in 3NF if every non-prime attribute is fully functional dependent at every key of R. No relation can be in both BCNF and 3NF. No. The direct answer. This is direct answer. Should not take more than 10 seconds. Basic, we just looked at the direct free marks, right? This is free marks. Free 1 mark, okay? So we know that for a relation to be in BCNF, first thing is what it should be in, which normal form should be the relation in? It should be definitely in 3NF. plus the left hand side should be a super key. So every relation in BCNF is also in 3NF. Okay, the direct answer, right? Direct. Yeah, another question. Try this out. Okay, saying it's not in 2NF. Okay. Okay, what is the first step? First step is to uh, convert the candidate key. What is the candidate key of the relation? AB. So 1NF. For 2, there is prime D, where the LHS, now let's try to club them together. The LHS is a proper subset of a candidate key. Is there a functional dependency like that? One second. Yeah, so I was saying um, to check for 2NF, the LHS must be a subset of the proper subset of the candidate key. Is there any functional dependency like that? No, how? There is no functional dependency. Seriously. How about this functional dependency? Left hand side is a proper subset of the candidate key. It will be right hand side is a non-prime attribute. So it is not in 2NF. That's it. Just done. Okay, fine. Now we'll do bit quickly. Okay, we'll try to speed up and try to come in the exam pace. Okay, next question is this. So it says there is a relation schema for these two schemas. There are functional dependencies. Assume that author and title is the key for both the. They are asking which of the following is calculated. Tortoise. Uh, my voice is breaking. Okay, should be better now. I came on a 5G network. It still breaks. I'm sorry. Okay. So what I was saying was they have given two schemas. Also key for did it break? Did my voice break? Is okay. Maybe we'll think. I think it will stabilize now. Okay. Let me know if it still breaks. Okay. So what I was saying is there are two dependencies, two schemas, book. They also told me for both this. And I think okay. I'm switching between my home Wi-Fi and Geo network. It still breaks. Let me know. Now so, book and collection. Operator saying so normal for
Sir, it's still breaking. okay. Let me know if it still breaks. I will try to look at something else. Okay. Is it better now? Okay. Thank you. So yeah, as I was saying, so yeah, so which normal form is book in? Which normal form is book in? Okay. So who are the prime attributes of book? See, prime attributes is easy to find out because they have already given the key, right? So what are the non-prime attributes? This is a non-prime attribute. 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 This is also a non-prime attribute. Okay. So far so good. Okay. Now, first look at book, right? First look at the schema of book. In book, the relation isn't 2NF, right? Because first there is a this relation, title author gives you catalog number, and title author is not a proper subset of the candidate key. And the second dependency has catalog number, which is a non-prime attribute. Since it's a non-prime attribute, for 2NF, you need not bother about it. And the third functional dependency considers publisher, year, and title deriving price.
Okay, considers publisher, title, year, dividing price. The right hand side is a non-prime attribute. The left hand side does not contain, you cannot say it contains a prime attribute, although it does, which is title, but it also contains non-prime attribute. So this is also not suitable for a 2NF specification. Okay, is the table in 3NF, which also means can you find out a non-prime to non-prime functional dependency? If you can find one, then the table is not in 3NF. So is there uh, something like that? I can see it directly from here. Let's see if you guys can see as well. Look at the second functional dependency. No. See, the third functional dependency you did not consider because it only contains both prime and non-prime attributes. Okay, since it contains both, what I mean by this is that left hand side should only contain non-prime. The right hand side should only contain non-prime. Okay, Vishnu. Look at the second one. Can I find out a non-prime to non-prime functional dependency? The left-hand side is catalog number, which is a non-prime attribute. What shall I put in the right-hand side? Such that I have a non-prime attribute. Can I put publisher? Can I put year? Right? I can put publisher, I can put year such that I get a non-prime to non-prime functional dependency, which violates the condition of 3NF. So book is not in 3NF. Okay. Everyone clear why book is not in 3NF? Okay. Now let's come to collection. Collection is simple, right? It's a smaller schema. So for collection, title author gives catalog number. So I have this functional dependency and to some extent this functional dependency as well. Right? I can say catalog number gives title author. Right? So is the table in 2NF? The primary key of this table is the key is author title, right? Here I have author title. This is not a proper subset. And here I have a non-prime attribute, which is okay. So the table is in 2NF. Now you have to check if it is in 3NF or not. Is there a non-prime to non-prime functional dependency? So let's say I put catalog number on the left-hand side. Can I somehow try to make a non-prime to non-prime functional dependency? Yes. How? How can I make? Catalog number gives what? Title gives author. What is title and author? Are they prime attribute or non-prime attribute? See, either you will give me saying, boss, either it is title or it is author, right? But both of them are prime attributes. I'm saying you, is there a non-prime to non-prime functional dependency? Is there a functional dependency like that, Vishnu? No. So it is also in 3NF. Now you check for BCNF. What does BCNF say? What does BCNF say? That the LHS should be a super key. Look at the second functional dependency. Is LHS a super key? So this is not in BCNF. Which option is correct? Book is in 2NF, collection is in 3NF. Option C. Let's go to the next one. I think I accidentally copy pasted it again. So this is the same question. Yeah. So this is simple. I don't want you guys to be confused, so I'll write the dependencies here again. Alrighty, first step is try to find the candidate key. Who is the candidate key? F1, F2. So prime attributes are F1, F2, and non-prime attributes are F3, F4, F5. Table is always in 1NF, right? It's always in 1NF. 2NF means there should be a partial dependency. Is there a partial dependency? Yes. There should not be a partial dependency. Sorry. 2NF means there should not be a partial dependency. If you look at the first two functional dependencies, both of them are partial dependencies. Why? Because the LHS is a subset of the primary key of the candidate key, right? And the RHS is a non-prime attribute. That's why this table is not in 2NF. So you do not have to go any further. Simply answer that the table is in 1NF. Okay. Okay. Two more questions. This is the relation schema that is given. They are asking the highest normal form of this relation schema. During that time in GATE, 4NF was also there in the syllabus. So you do not have any more. So I'll change this option to NOTA. Okay. Yes. What is the correct answer? What are the candidate keys of the relation? NCRC. Name, course number, roll course number. Okay. Good. Good. Very good. So who is the non-prime attribute? Grade. Okay. Grade. Right. Grade is a non-prime attribute. Okay. So you guys are saying that the candidate keys are name, course number, roll course number. Okay. Let's directly check for 2NF. Prime attribute to non-prime attribute. Okay. If you look at the first two dependencies, they contain a non-prime attribute on the right hand side. But is the left hand side a proper subset of any candidate key? No, right? Both of them are actually the candidate keys. Name, roll number, course name, course number, roll number, course number. So this is in 2NF.
Now check for 3NF. 3NF meaning, is there a dependency like this? Non-prime to non-prime. Do you see grade on the left hand side in any of the dependencies? No. So there cannot be a non-prime to non-prime thing. So it's not in, it's in 3NF. Sorry, it's in 3NF. Is the left hand side of every functional dependency a super key? Hmm? If not, who are the culprit? Name, roll number, name. If you look at these two dependencies, the name and roll number are not super keys. Are not super keys, right? Right. So because of them, boss, this table is only till 3NF. Okay. Clear? Can I proceed? Okay. Last question, theory question, very simple question. And this will be BCNF. And I will change this to 1NF. Which normal form is considered adequate for a normal relational database design? In other words, which normal form is the best normal form for database design? Remember what I said in the start of the lecture. Hash NF, okay, 3NF, right? So 3NF is the normal form which is the most adequate for normal relational database design. Okay, so this was all the set of questions I had. It covered various aspects of the normal forms. Again, I would suggest to keep these slides with you. Okay, please have them handy because they list also these questions. See, there are more questions given in the internet. So the thing is, why I put these questions is I selected this question as very important questions for the exam because it will help you to have a very holistic view of how the entire normalization thing works. I discussed starting about the different anomalies that are there. Why do you need normalization? You break down the table into two or more tables such that the redundancy is eliminated. Anomalies are eliminated. What are the different normal forms and what do they mean? So 1NF means composite multi-valued attributes are not allowed. 2NF means 1NF plus no partial dependencies. 3NF means 2NF plus there should not be a dependency like non-prime to non-prime. BCNF means 3NF plus LHS as super key. The best normal form is considered 3NF because it always guarantees a dependency preserving lossless decomposition. And always this, remember this, a relation with only prime attributes will be a 3NF. Okay, please keep this in mind. A relation with only prime attribute will be in 3NF. Okay, any questions before I end the lecture? Anyone has any question before I end the lecture? No, no questions. All are experts in normalization now. Okay, good. That's the expectation. Also, please, my suggestion is for people who are new to this topic, please try to learn this topic because this and the previous topic that I taught you, which is functional dependencies, they are very, very important for your GATE exam. Very important. Okay, don't go inside the exam without learning these two topics. That's how uh, bluntly I can say things. Okay, so please try to learn these two topics. Surely there will be a question. Okay, in the next class we will solve some questions on the topic relational algebra and relational calculus. It's a very simple topic. Some tricky questions are always asked. We look at those tricky questions. So please be prepared. Come prepared. And the next class will also, I'll give you a quick overview, like a cheat sheet, and then we will solve some questions. That's on Friday. So
Friday will be a class on relational algebra, relational calculus. Thank you for joining. If you have no questions, feel free to exit the room. Slides are already available in the chat window. Thank you for joining. If you have any questions, feel free to ask. If you don't have, feel free to exit the room. Make sure you download the slides. Okay, no questions, I guess. Thank you for joining. We'll meet on Friday.